Hello! Welcome to the bonus stream. It is Monday, October 13th. Today is Indigenous Peoples Day in the United States, formerly known as Columbus Day. And so it is an official government holiday, which means that I am also off. So I thought I'd do another stream today. Yesterday we got pretty far into writing x86 assembly. I mentioned on the stream yesterday I wanted to do something kind of different as a bonus stream, and I think we'll do that. So we got a portion of our x86 assembly done. And I wanted to update our Compiler Explorer UI. So if you didn't see it on a previous stream, let me pull it up here real quick. Okay. So let's get started. So this is, and I messed this up, this should say essentials. It says elements, because I'm a fool. So previously, like, if you could do that, you could see what it compiles to in terms of the x86 assembly. And we did this kind of manually. We can also do an interpret, and it gets, what is the output of that program. Hey, Chris. Great stream from you earlier today. Thanks for that. Thanks for joining mine. So we're going to update this, and the goal here is we're going to make a drop down or something next to this compile button. Maybe we'll put it out here to the right. Maybe we'll flip some things around. But what I want to be able to do is compile to any intermediate phase and see what the AST of that looks like. So it's going to be an interesting challenge. But we're going to make use of this package called Gleam. Again, not to be confused with the graphics math library in Rust. Unfortunate naming. I understand why Giacomo made this called Glam. It makes things pretty printed, so it's glamorous or something. I don't know. Anyway, most importantly, it works both the Erlang and the JavaScript. Yeah, Glam, not Glam, right? Works with both the Erlang and the JavaScript targets. So we're not going to have any problem running this in the browser. So let's get started. I was looking at what's in our UI. We have this compile module, which is, I stubbed things out, and you're going to see here what we did previously was what am I trying to say? We just passed things through every phase for the compilation, and for the interpreter, it does the parsing and then passes it to the interpreter for the language. So we'll probably update this. Remember, our UI is using Lustre, which is kind of like the Elm architecture. What other? I'm trying to think of what other front-end frameworks it would seem like. I'm certain that there's one in Rust that kind of looks like the Elm architecture. So, but you have a model. All of your side effects are messages that are scheduled by the runtime. And then what you do is you provide an initial model, you provide a function that takes a message and updates the model. So this feels a little bit like Redux, right? And then your view just takes the model and produces all of the markup for you. And we fought in here. I'm going to go ahead and fix this. We fought with a lot of tailwind. So we're gonna probably not mess with the we're not going to mess with the UI design right now. Maybe what we'll do is we'll just add the button, the select thing, and then move on with our lives. My intention today is to go as long as I can stand. So if you can, I usually try to keep it pretty much within 2 hours, but if you can stick around, I might go longer. Just depends on how I feel and whether I get tired of talking, which is very, very possible. Okay, so we're gonna go. We're gonna look at Gleam, and I did some Gleam tutorial projects that were. Let's see. So we did pretty printing a list. We did JSON pretty printing, and these are pretty instructive. So if we do Gleam run, you can see here we've got this is Gleam style lists. So and here's some simple JSON where it comes out in one line, and then nested pretty printed JSON that depends on what the width is. So here we said the width was 20, and we got it breaking instead of going across one line. So yeah, we're gonna do something similar to this. I've been this morning reviewing the tutorials just to make sure I kind of understand things, but we'll probably refer back to this project when we're trying to do our own languages. And I think I want to start with, let's see. I want to start with either something in the middle, so like the C like IR, or maybe the x86, although we haven't gotten all the way to the bottom for the current chapter, so maybe we could do the one that we just created, the x86 global. And then the Lisp-like languages are going to be, as far as formatting, they're a lot more subjective, I think. And there's things like maybe for a simple 2 argument operation, you want to try to not break that. But like if you have a begin statement, yeah, you absolutely want to break things after the begin. So there's going to be some interesting things there where we have to make decisions about what do we prefer to break on. And I don't know that there is an established convention in the Lisp community about how to format. People use all sorts of different styles, and it's very context specific. So producing that is going to be interesting, for lack of a better word. Okay, so we'll refer back to this, but let's go ahead and go into our languages, and let's go to C-tup. So this is the 3 address code like language, right? So that it looks kind of like this. And I think that we can do something like that. I personally would probably do, if we're pretending it's C code, I would probably put curly braces on some things. I suppose they're not strictly necessary. Note that they kind of intermix Lisp-like constructions with C-like constructions. It's kind of funny, but it's okay. Another thing that is interesting to point out here is that their function calls are surrounded by parens rather than trailing parens. So I don't know how I feel about that. But if we could get, say, like this as an example, and get that to pretty print, that would be awesome. Okay, so What's our first step? We're going to Gleam add Glam. It's a mouthful. Okay, so we've got Glam. And what I want to do here is import Glam doc. Okay, and we're going to make a function in here, which is, we'll say format program. And this is going to be return a document. So Glam document. All right, so what do we need to do? The C program, we don't really care about this info. It doesn't affect the contents of the program. This is just information for passing through different phases of the compiler. So we can ignore that. So let's say the general pattern here is that we want to have something for a block, right? And then we'll concatenate all of those together. So let's say, let's make a stub of a function. And we'll say name. So this is just taking the key value pairs out of there. Tail, and that's going to return a document. And then we can do stuff like map over them and so forth. Okay. So we're going to take input.body and we're going to say dict list. So that's going to give us a list of pairs. And we are going to map. I wonder if we could do dictionary map. No, you have map values. So let's just do toList. It's fine. And we're going to, this is going to take a item, which is a string and a tail. And we don't actually have to specify that. I think the compiler will infer it. And then we're going to just return format block item.0, item.1. And then we're going to do doc. For now, we'll say concat. Why do you not know anything about this type? Okay. Import Gleam list. Okay, now it knows. Okay, that's not so bad. We'll probably need to tweak this a little bit. If we want something that looks like this, we might need to, rather than concat, maybe force these to be joined with new lines. Yeah. We can actually go ahead and do that force break. So that's just going to make sure that each of the items inside this document start on new lines. But honestly, I'm going to leave that out for now. We're going to see what we get. And I think that it might be nice to... We're going to make a main function here. Sure, fine. So what we're going to do is we're going to take like a sample C program, maybe from one of our tests. Yeah, let's take this one. The other thing we could do here is just, you know, parse this and pass it through all the phases. That's another possibility. But here we have one. So what I want to do is And here we don't need to qualify any of these. Okay. Replace that with nothing. Okay. So, let's see, L dot. Do we have that? Yeah, let's call it as L. Then we get the thing. Oh, it removed. That's fun. Okay. So what we want our little main function to do here is we want to take our program and pass it to format program, and then we're going to say doc.toString, and I don't know, 80 columns is fine. We'll find out what works later. Okay, so now obviously this is going to panic, so we can't really run it. But here we could do eoc langs ctoop run. Oh, where's the other do concat? Oh, I guess I have to save it. Okay, yeah, so it's just giving us a to-do. That's fine. Okay, so we have the basic here. Let's think about how to do a block. There's 2 bits to this block, right? We have a start label, or whatever the label is. So we need to make the label, and that's going to be doc from string, and we're going to say name and concatenate with the colon. And we're going to do this really dumb at first, I think. So because we want to what am I trying to say? We want to get something printing to the screen and then see how to tweak it. I think that's what we would like to do. So we have this, and we're going to join that. This is not going to be right. We're going to say format tail, because that's what it's called. And I think, here, let's pull this out. We're going to do that. We're going to need breaks and things in here. We'll figure that out later. And I think it might be more like we do format tail, prepend, label. We're going to nest. So we're going to nest the tail by an indentation of 2, it looks like. And then we're going to group. So when you group, that ensures that, let me pull this out. I'm sorry, my Elixir brain is telling me that needs to be in a separate thing. When you group, that says that when you're forcing breaks, this is where breaking will stop. Like, or the things inside of it will be line broken all the same way. The interesting thing is here, we're going to make sure that every statement gets its own line, regardless. So that'll be interesting. But here, that'll give us, this nest will give us this indentation we want underneath the label. Okay. So tail is going to return a doc.document. Okay. Now, the hard thing about this is this first pass is going to be like getting familiar with the pretty printer formatter, and then when we're more familiar with it, we might know better what to do on future languages. But what we can do potentially is what we've done a lot of times when we like copy and modify. We can take once we've done one of the Lisp like languages, we can make it happen for all of the intermediate languages that are kind of like Lisp in the middle. Some of the phases don't actually change the language; they just rearrange the syntax. But some of them add constructs, some of them remove constructs. So we won't necessarily be able to directly copy all those things. Anyway, so here we are, format tail. So here's where we actually need to do a pattern match for the first time. Okay, so go to should be straightforward, right? We want to make a we'll make a string as go to. In fact, we can probably make this a constant. Although this is probably the only place that we're going to do this. So there are some constants in Glam which are spaces. And I think I want to use this one. There's also this flux space. And I think that that's more like if you want soft wrapping on things. So like, let's say you have a to-do list and you're rendering a single item in that to-do list, but the text of that to-do item exceeds the width that you're trying to print at, right? If you put flex spaces in there, then it can pick any one of those spaces to break on. And that's what this flux space is about, versus a regular space, which is it like prefers to be on the same line but will only break if necessary. So that is how I understand it. I think let's see. Right, so this is deciding on space by space basis. A regular space is one or all. The other thing that we could do here is just say, you know, there is no break, right? And actually that's probably the easiest way to go here, because we don't actually ever want to break this. Let's do that. And then that gives us the opportunity to put the semicolon in there as well. Okay, so let's come back to the if. Okay, so return is going to be, yeah. Let's really quickly look at our list printers and our, okay, so there's also this soft break. So that's rendered as an empty string. Okay, I want to look at this break function because we may need to make use of it. Okay, so this is a document after which the pretty printer can insert a new line. A new line is added after break document if the group it's part of could not be rendered on a single line. Okay, so in this example, they have a string, they have a break which has a dot or a return sign, and they have another string. And they concatenate those and group them. So if it's, wide enough to print it, it puts the dot in the middle. If it's not, it puts the return sign and a new line. So that's what break is. And like this soft break is based on break, and that's just an empty string. So like, why is this useful for this list? Well, when you have the soft break here, if it's printed on one line, you don't want a space after the opening bracket, right? If it's printed on multiple lines, you don't need a space after the bracket. But you want to be able to say it's okay to break right there between two things that would normally be completely adjacent to one another. So that's why we have the soft break in here. Our comma is just a comma, a plain comma, and then the space is, so if it's on the same line, it's rendered as a space. And then if it needs to break, then there's a new line, and there's no additional space. Okay, this is coming back to me. Okay, so in this example, we take this list of strings, we map each item into a document, which is basically this, wrap it in quotes. We join it with the comma. We prepend the open square bracket. And this is the part that I don't understand about the API, but I'm just going to take it as it is. We nest the contents by 2, so if they are inside, then we will indent them if they break onto a new line. And then you append the closed square. Yeah, it's what I never understood about this example was, why do you not nest and then prepend and append? Not sure. And then you put them in a group so that they're treated as one thing to operate on. Let's look at the JSON example real quick as well. So, excuse me, quoted string, right? I made this, and I actually should have done this on the other one, but this is basically like replace all the quotes in there with, escaped quotes, so they're JSON valid, and then, wrap it with single quote or double quotes. And this one is like just float to string, turn that into a document. For numbers, for booleans, it's really just, turn it into a string, lowercase it, and then into a document. Null is just static, right? A static document, basically. And then array to doc is, we have this parenthesize helper, which we might make use of in our stuff. And it's basically like, take a document, prepend the opener, nest it by 2, append the closer, group it, is essentially what we saw in the other examples. Okay, so what am I trying to answer here? Return, I think, is just we have the return keyword, and then I think we're just going to doc concat, and we have no breaks in here, so we're not adding any breaks. And we need to format expression for the inner part. And we'll define that in a minute. And so this one is going to be This is going to be interesting because if we have a statement and a tail, we basically need, and this is going to be wrong, but we need to format statement and format tail. Right, so we need to recurse into the tail, and these are joined with one another. Let's make that function. We're going to make format expr, the document. Let's stub those out. I wish, here. Generate function, thank you. Yay. I guess these don't need to be public. Yeah. Format tail doesn't need to be either, or format block, unless we want to test them. Okay. And finally, again, this is going to be wrong, but we're going to figure out how to do this. And then when we get our the rest of our stuff figured out, we'll have better formatting. So we have if, and like it's going to be an expression after that. I'm going to put the space in there. We may want to reevaluate that. So condition is an expression. The interesting thing here is that I think that we can force lines. So line always printed as a single new line. Okay, so we can force a line break like that. That's interesting. So maybe what we do here is concat join with doc line. Okay, the other thing here is that, you know, in their example, and I'm going to make this a little bit bigger, they're using inconsistent spacing here. This is an indentation of 3. I kind of understand why they want it to line up with the expression here, but I kind of hate that. So, I'm going to try this. We're going to indent that by 2. I'm going to force a line break there. I don't know that that's the appropriate thing to do. I feel like there's maybe a constraint that we can put on this that's like, yeah, you need a line break after this. And then we'll do format tail on the if false branch. And then that covers all of our tail AST. Okay, so for statement, again, we're going to do S, add the missing patterns. So for an assign, we basically do this, right? Something equals the expression semicolon. All right. So we're going to take the variable, and then we're going to make a space. I don't know that this is the right way to go, but here we are. We'll make the equal sign, and then we'll say format expression, exper, and from string, and then a semicolon. I think honestly at some point we're going to have constants for those. The whole reason we have all of these functions we call is this document is an opaque type. It has variants, and those variants are used internally to drive the pretty printing algorithm. But what am I trying to say? We don't construct those variants directly. Okay. So this one is going to be fairly simple. We're going to have the word collect. We'll do concat join. And then we'll have doc.from string int to string of amount. And then we'll do that parenthesized dance. So let's go ahead and make a helper, or we honestly copy that helper from the other project. Yep, parenthesize. So we'll do, and I'm gonna break this out into a pipeline, I think. And that's gonna probably force it on a new line. There we go. Okay, and then we'll do parenthesize, our open paren and our close paren. Now, there's not any reason that that should ever be broken onto a new line. But here we are. We can reuse that. Okay, read statement is really just parenthesize doc from string. Now, the other thing that we could do is, since the only parentheses we use are curved, we can just remove those arguments and just say it's always that. That works for me. And then we can get rid of those. Read. Okay, so the other thing that needs to happen here is that we always need the trailing, since this is a statement, we always need the trailing semicolon. So I'm going to have to do that here. We might as well pull this out into a pipeline. And actually, you know, let's just factor it out because it's on every single one of these, right? So we can put it at the end here potentially. So that'll eliminate some duplication. The interesting thing is, I think we could do. No, we don't need to do it here because this like has multiple semicolons, and there'd be a question of like, well, where is the semicolon coming in? Is it here or like we don't want to. I was about to say we could do the same thing with this function, but I don't think that we can. It's too different. I almost want to cheat here on this one. Because I feel like this is going to be repeating some stuff that we do in when we do format expression. Well, let's do it this time and maybe we can copy it. Basically, this is just a vector set where you're not capturing the return value. So let's do something similar to what we did before. So this is from string and vector set, right? We have a space. We have an atomic. We have another space, and we have. And actually, we can probably remove those and just say format expr value, and then we concat join with doc space. And then we'll parenthesize. Okay, so we have our, oops, generate a function for that, please. Oh, interesting. So at this phase, that's actually not an expression. That's an atomic as well. Cool. I forgot about that. Okay, and V is also atomic. So we have format atomic of V. Right. Okay. You know, this is starting to get into a rhythm here. We'll figure this out. And this, I need to rename this variable. We'll call it A. There's not too many here. So for bool, we have what we did in the other project, right? Bool to doc. There we go. I suspect that what we'll probably do is have some of these things into like maybe another module. And we're repeating this, you know, integer thing as well. So let's extract that into a function. That's not what I wanted to do. This one's easy. Hello, Bianca. My cat's talking to me. I need to put a to-do up here so it doesn't blow up the editor. Okay. So this is int.toString. And for clarity, I'm going to make that I so that we don't get it confused with the module, doc from string. Okay, so that one's easy. Here we do int to doc value. And then void is just the string void. Okay. Okay, that one was easy. So we actually have a couple places up here where we did this. This is going to be int to doc of amount. I think there's one more up here. Maybe not. Okay. Well. Okay, so let's look at expression, and this one is probably going to be the biggest pattern. Yeah, so what we're probably going to have to do here is explode the primitive operator. So let's do this for, I was trying to move it up a line. Let's do atom first. This is really just format atom, because when you have an atomic at the expression level, it's just the atomic. That's how it would be printed. Okay, so allocate is like a call. Yep. So this is allocate. And then we're going to have to say format type T, which honestly should go, yeah, I know it's not in scope. It should go in this other language, right? Because the type, we're just reusing it. So I'll go ahead and we'll make that be L dot format type. And hopefully that should be easy to do. Okay, and then this is going to be and I think that we'll remove the spaces there. And doc.concat join. Yeah, we need to remove this concat here. Starting with the list, concat join with doc.space parenthesize. Okay, and then global value is similar. It looks like that. Because var is a string. Yep. And then we go do the same dance here. And now the other thing that we could explode this here, but maybe I'll make a separate function. And I think that what we want to do, or what we can do in here, is not worry about the parentheses and just say this is, or format op, and then parenthesize, because these are always going to have parentheses around them. Okay, so case op. The other thing that we can potentially do here is go, if this returns a list, we can make sure that all of these arguments are joined with spaces. That'll be nice. So then our stuff can look like, this one's easy, right? Plus looks like plus and format atom A and format atom B. And this looks like, yeah, this will be helpful. So we're getting down to the nitty gritty here. And we can do the same here. And we can just copy this for minus. Minus. We'll need to have a conversion for the operator, which I think that we can do in the other language because this type is borrowed from there. So let's do L dot format comp of op, and then we'll say format atom A, format atom B. And we're nearly done with this. So vector length is going to be I think it's vector len. Vector length, it's the full word. Okay. I'm sorry, and V is an atomic, so we need to do atomic V. And you know, this just, you know, is a bit repetitive here, but we're getting close to the end of this one, and then we can go and add some pretty printing functions to the other thing. And what I want to get to, yeah, that doesn't have a bang on it because it's not mutable. What I want to get to is that we can fully pretty print this program and see where we need to adjust how it constructs its documents. No. Yeah, and here, note that we're kind of doing the same thing we did on that statement, but that's okay. Nah, no harm done. Okay, so there is no definition of format that. So let's go over here to L2. And we're going to make pub fun format comp. And this is going to take an op, which is a comp. And this is going to return doc.document. And we will need to import, because we're eventually going to get here, right? Okay, so we do case op. This is going to be really straightforward. Honestly, I'm going to do it the easy way. All right, that one's done. We have one more that we need to do that needs to belong in the top level language because that's where the type is defined. Format type. So it's this. And what I want to see down here, so I'm going to have to page back down to their sample. Right, so they basically print it without the, you know, we have integer t, boolean t. Okay, and it's becoming obvious to me that here in a moment we're going to need to put that parenthesize helper into a separate module, and we may need to do it with some of those other things too. So that would be a good time to do it once we get to, like, see this nested stuff and with the parentheses around it. So let's just fill in all these. So this is going to be from string boolean integer void, and vector t is going to be, these are the fields. So this is going to be we're going to have first the vector, and then let's see, maybe we do it like fields. Hold on. We're going to map right, so that's going to get a list. I wonder if we can do it like this. Hold on. There's a little syntax thing I'm trying to consider here. And I don't know if we can do it with, yeah, it doesn't like that. Oh, it's actually complaining about that. That's actually fine. Yay! Okay. So I don't know how this compiles out, but basically you can do a spread if you're adding something on the front. And then we need to do parenthesize. So what do we call this module? Well, let's call it pretty. And I'm going to put it in here because it doesn't really belong outside. We're not going to use these. Let's see if there's a helper. No. There's no code action for move this to this other file. So what I'm going to do is I'm going to put it in here. Import glam doc. Okay, so we're going to put that in there so we can reuse it, and we'll say pretty dot parenthesize. And actually, we'll just import those so we don't have to requalify everything. Oh, hold on. Wrong file. And then, so we're going to say yeah, I just imported it. What's wrong? Oh, it needs to be pub. Okay. So if we go over here, I also want to extract those other two small helpers, these. And we'll make them pub. I think this is, oops, import Gleam int. Let's rename that to B for clarity. Then this will know import Gleam bool, import Gleam string. Okay. So now we can go up here and we can say int to doc, bool to doc. And then we don't need those imports because we are no longer writing that in this file. Okay, so we have format type now. And what are we missing from this pretty printer? I don't think we're missing anything, so let's see. Maybe I'm wrong. Okay, so we've got a lot of mess. For one, our if else is incorrect. We need else, right? Our indentation for the statements is fine, at least on the first one. Note that our types came out correct in that allocate statement. That looks good. So I think we want to make sure that the label gets broken. Let's start with that before I make any other changes. Okay, so there's always a break on the label. On a tail, I think we want to doc.append a new line. There's a question in my mind about whether that should always be part of a tail, but at least let's get that going. Okay, okay, closer. Look at that. I think we want 2 new lines just for clarity, right? Yeah. Then we get separations between the blocks. That feels better. Note that I didn't like hand code any of this. This is just the constructing the documents and letting the pretty printer have at it. Okay, so we still need indentation on our go-tos inside if branches. So we need to look into that. I think that this nesting is not working. I wonder if we need force break to make that nest. That might be wrong, the wrong way to go about it. We could... That doesn't change anything, yeah. We could potentially, rather than using this nest, which is dependent on are you breaking or not, and just say that this is always nested. So, and what I mean by that is we put some hard spaces in there. That's probably the way to go. Let's go ahead and look at the API docs real quick, because I think that what we want to consider we don't want that. Empty document, we don't care about. I think that we just need to do this the hard way. So we're going to remove the we might want to rethink the structure here. I'm going to make a we're going to say with indent, which will force an indent rather than this nest, right? Because the nest only only affects when something needs to be broken on multiple lines, and we kind of want to force. So this is an int, and this is going to return a document. So what I want to do here is concat, and we're going to do string dot repeat space amount, and that's going to be talk from string, and then we'll say d. Here, I'm going to unqualify that. We're going to use it all over the place anyway. Okay, so then we can say this is a pretty dot with indent. We're going to take format tail 2. And we'll do the same here. And then that basically replaces our nest. So see if we get what we wanted there. Okay, so now our go-tos are being indented for the if and else. That's good. Let's see if we can clean this up a bit. So note that all of this, we can potentially make this into a concat join with lines, right? So let's remove the lines from there. And this needs to what is prepend? Prepend takes, let's just do dot concat just for clarity. We're not changing the format. Okay, so let's do concat join on this, and then we'll do with doc.line. And then we get sort of the grouping of the lines, right? Like there's the if with the expression. Oh, hi, Vadim. Welcome to the stream. Sorry I didn't see that. Yes, this is the Z editor. I'm using Z. I was very heads down into this problem, so I didn't see your message. Thank you. Okay, so then we combine this. This is a new document, so we're not joining this with lines, but we will join all of that with lines. That feels better. And that kind of follows with what we were doing down here. If there's a sequence of statements, we format the statement, and then we follow up with whatever follows that, the tail, and then we join them with lines. So that makes sense, and it kind of follows the same pattern. So let me make sure I didn't break that. Yeah, so that still worked. And now we've got pretty printing. Now we have a problem here. We have a void. Oh, Adam. Note this void here. This should look like a function call. So I'm wondering, I think we just need to parenthesize this, because I don't think that there's any other case where let's see if that fixes that. Yeah, okay. Because it's kind of like a function call constructing the void value. It's not a global value. Okay, so let's make sure that kind of looks. Yeah, so the global values are not quoted or anything like that. when we get an allocate, we've got it wrapped, the types. Note that we've got the types there. That looks good. Our vector set looks correct. All right, good stuff. So we essentially have the same program as them, or just, you know, our variable names come out differently because of some of the order of operations that we do things in our compiler. But you will see that like the basic structure is the same. The start block, with the exception of, remember from our previous sessions, for whatever reason they figured out that this was an immediate value and inlined it rather than assigning it to a variable. We assign it to a variable. So, whatever. One thing we might possibly do is pull out start and have it print first, but I'm not too fussed about that. Let's look at it. Okay, so start global value free pointer, add 16 to that temp variable, and then get the global value from space end. If less than, go to some block, go to some other block. So their block 0 is our block 5, and that's basically the same. Underscore 4 is void, go to block 4. So their block 4 is our block 9, or their block 9 is our block 4. And then on the block 6, we have the collect 16, right? Because that's what we were trying to allocate here. Collect 16. And then if block 4, which is their block 9, so allocate 1 vector integer underscore 3, somehow we got that the same, is vector set on that allocated, we got alloc 2 as well, by the way, 0, and then so here's where we had set this to a variable and they just inlined it. Okay, I mean this is feeling really good. We got something that looks like their output, and this is the basis of what we can do in some of the other files. Okay, so now I don't know that there's anything specific here that we can extract yet. So let's go back up here. We have these two functions that we exported so that we could use them from elsewhere. Let's go ahead and make a format program. And that'll be our program. And it's going to return a document. And we'll go through this for this language, and then we can probably copy paste into the what are the different passes here? Let me go down to, we were doing the select instructions, right? So if we look at this, we type check the program, so that's still the original. Uniquify returns the same one. Expose allocation returns alloc, so we'll need to do that next. Uncover get is also alloc. Remove complex operands goes into the monadic form. So that's where we get rid of non-atomic arguments to primitive operations. And then that goes, so we have 3 to do here. We have the top level one. We have the one where allocations are explicit. We have the one that's a monadic form, and then we just did the C. So I think if we get through that, that'll be really great. And this is not going to be bad. So in this one, it's going to be mostly mostly this, right? And we'll get to play with, because there's nothing else in this type, right? It's just the body of the program. Yep. Okay, so our big one is going to be this format expression. Okay, case E, and here's where we do all this. So we're going to have to, I want to actually pull this up on the right side here so we can look at it at the same time. All right, so let's get the primitive things up here, because those are all pretty simple. The has type, I don't think that we will pretty print that. We could. There was some stuff in this chapter. It was like about how do you, yeah. So we could do has type as a thing. Yeah, that's fine. If we haven't run the type checker, there's not going to be these has type wrappers on things. So we don't, you know, we wouldn't have that wrapper on it. But if we have type checked, it's still going to be of this same program. It's not a different data structure. It just has these wrappers on it. So okay. So this is going to be easy. This is going to be pretty bool to doc, right? This one is going to be doc from string name, because a variable is just a bare name. Integer is going to be our int to doc. So those are straightforward. Let's do, and this is where it's going to get interesting. So this is going to be, we know what ultimately what we're going to do is we're going to parenthesize whatever we do is going to be passed to parenthesize on this one, because we want to have parens around it. I think that we need to look at, for begin, it's basically like we make a list. So let's say format, let's do list.map format statements, format expr, and this is not correct. Then we want to do list append format expr result, because result is the last one. And we kind of need to do something similar to what this parenthesize does, but we have the begin keyword, or function call if you want to call it that, that is gonna prefer to have a line break after the keyword. So if we go in here and let's search for begin. Note that, like, generally speaking, you break and then indent, regardless of how many things are in the begin. The interesting thing here is, though, we may need some slightly different rules for the trailing. Because we want the trailing parentheses to be on the same line as the last thing. So we may need to eliminate that soft break. We didn't run into a problem here because our width is wide enough. Maybe let's go over here, and I want to pick kind of a decimal width, like 20, and see what happens to some of our expressions. I don't think we'll ever use that, but yeah, look at what happens. Look at how that explodes. So we'll definitely need to look at maybe using hard spaces instead of breaking spaces on some of those things. Improvement for later. But for this one, you know, this parenthesize function I really think that we need to not have the break. Let's remove the soft break and turn this into prepend. So we remove the soft break. And this doesn't need to be a list anymore. And the other thing is, I think that we do it like this, because that way, I'm missing a paren. That way, these will hug the inner documents. Let's see what difference that makes. Okay, so now we get this, you know, again, very decimal. But what we can do in our we can make a non-breaking space. And I think that that will get us what we want. Yeah, so then even when it's, so we need to fix some other spots like this allocate. We didn't adjust all of that. But for these primitive operators, we're getting non-breaking spaces. This is in a different language, of course, so we need to think about how we handle that slightly differently. But so I think in here for our format type, we need to join these with flex space rather than space. So this was consider each of the spaces individually for breaking, and then we'll get something slightly different in here. So, that's not great. We need to go up here and allocate. We're just going to say from string plain space. Now it's breaking, like the weird thing is, I don't know. We might need to throw some indentation such that, like here, this gets pushed over to the right rather than wrapping directly under there. Like it should, we're really not consistent in here. I didn't fix that global value. Yeah. Okay, so this allocate still looks weird. Note how it breaks like that. What you would want, and especially in a Lispy thing, is for this to be indented at the same level that this is. So we may need to look at some of the other tutorials to see like how that should be computed. And I did, here they have up here, learning materials. So, okay, so this is about, we don't actually want that. This one with the error messages, I didn't walk through this one, but this is sort of like, hey, let's print something that looks kind of like an error message from Rust, right? Where it's identified the span of the thing that needs to be underlined, and it generates the correct number of underlines for it and indents it correctly based on what is the prefix of that line and so forth, and then aligns everything for that. So again, this is about that that flex break and flex space. Yeah, so we maybe should make more use of this flex break. All right, so this is the example. They're taking some long text, splitting it on spaces, and then joining the documents with flex space, and that lets it wrap to whatever width. And then if you do nesting, yeah, so it's like we need to figure out we need to figure out the nesting of the type, and in general this would be a good thing to figure out for our Lispy type stuff, because if we have we'll make more use of nesting here. Okay, so let me. So we're gonna force begin to have all of its stuff broken on lines. And then we want to do prepend docs, and we're gonna say from string begin, and then break. Not soft break. We'll just say doc line there. And then we'll do doc nest by 2. Oh, for Pete's sake, Sean. Parents. Okay. And then we'll say group that. So let's look at our parenthesize helper. I don't think that it is grouping that. So we'll just put parenthesize in there, and that'll be sufficient. Okay. So I think that we need some sample we can run here at some point. But maybe what we should do is go. We don't need that extra nest. We should finish the rest of this, right? We need to do the primitive operators. And then we'll see what we can get here. Again, if we get this done at the high level, then it'll be a matter of copy modify for the other intermediate representations. Okay, so has type. This is really we've got whatever this is, format expr of the value, format type t. And then we're going to have this is going to be from string has type, and then we're going to do doc.concat join. These are going to be with flex break, not flex space, because we kind of want those to be on the same line. And then we'll do parenthesize. Okay. So the interesting thing about if this is one where we want to kind of group things, sort of like what we did over here with which one was it? Like this, we grouped the if and the condition together, but we'll want to make sure that there's breaks between the if true and if false. So it's going to be like if we want a flux space And honestly, I almost feel like that should be a hard space. Because you really do want the condition on the same line. And then we'll format the expert for the condition. And then we want a line. And the thing is, I think that we want to do it like so. We want those to be treated as one document. What did I do wrong? Got something really wrong there. Okay. And I think I'm going to hide this so I can see more of this editor. Okay, so it's just complaining we don't have if true or if false handled. Okay, so we want, that's our first line. That's our first line, and then we'll have format the expression for if true, format the expression for if false, and then we will make sure that we okay, the main thing here is that I want this one to not break, but I want these to be forced onto new lines. So that's why I have this with docline. Okay, so we're gonna have to do a similar thing for let. So let's just copy and modify. This will be let, and then there's gonna be a space, and then the binding is, so we're gonna have, let's just go ahead and put, it's gonna be like that, right? So we have the variable, and then we have the expression, the binding, and we're gonna have a space here. I'm really gonna have to define that as a constant at some point. And you know, this is kind of like parenthesize. And this is expression, probably goes on the next line. Except this one, I think I want space, because it's, in some cases it's fine to have it on the same line. You just kind of don't want it to break in there. You want it to break after, like between these two. And maybe that's actually soft break. No, it's just space. Right, so renders a single white space but can be broken. Okay, that's what we want. Yep. Okay. So now we get to do the dance with primitive operators, but maybe what we'll do instead is do these others first, because, you know, while loop is very similar to these two. It's that you have a while leading it. You have the whole thing parenthesized. You have while at the front. You want the condition to go inside or be on the same line if possible. And then the body should be on another line. So, you know, not absolutely necessary, but generally speaking, you want it to be on another line. Okay, so we'll do something similar to what we did above. We have while. And then we'll have a hard space, a sticky space. I mean, that's what I'll call it. And then you have the expression of the condition. Okay, and then we'll have the expression of the body. And we will do our concat join here. I think I'm going to make line, and then we'll parenthesize. Okay, we are getting near the end of this one. The primitive operators will be like, we'll call in there and we'll have it print out all of the stuff, and then we'll parenthesize it. And we may even be able to copy that from CTOOP and just modify. That's a distinct possibility. Okay, so set bang is actually I think it's that. Yep. Okay. And then we have and then we have format expr value, and then we're going to we'll make that doc.space. That's fine. And we'll parenthesize it. Okay. All right. And this is just going to be op, format, op, and then parenthesize. Okay. It knows the type of this thing, so let's convert it to... Oh, that's not what I wanted to do. Fine. Will you let me generate function? There we go. Convert to pipe. Thank you. Okay, so this is going to look really similar to what we had in the other file. So honestly, let's go in here. Yep. Let's copy it. It's probably going to complain. Yeah, so now these are not format atom, they're format expression. So we'll fix that. It's not complaining about missing. We're going to replace all of that with format expr. Here, replace all of them. It's not complaining about missing any branches. Right, this is just named differently. I need to fix that. Okay, so now what's wrong? Add missing patterns. All right, so in our lower level language, you don't have and or the vector constructor. This one's easy. Void. So vector is going to be, and this needs to be a list. Vector. And we'll do list map fields format expr. Easy enough. Okay, so I think that we've got everything. We're gonna have some problems potentially with like the begin, these other things. I've inconsistently used line and flux space. It's not always clear to me when to use which one, so we're probably going to run into some issues. But let's write a little test. And we'll say pub fun main here so that we can just run it. And I'm going to do, we'll use our example from our test that we've been using, this doodad. Okay. And we need, we're actually going to do use all right, we're going to look at Gleam result because I think that that's going to help me out here. I'm going to try. Yeah, I mean, I think we're going to do something like this. What I'm doing here is I'm just going to do let underscore equals this so that we can throw away the result. Okay, so we're going to do result try, parse tokens, and we're going to, what do we do with that program? I just dropped it. Okay. So this is going to be our program. And we'll do use p result.try parse.parse tokens. Okay, and then so p should be a program. Then what we're going to do is p format program IO print line, except we've got to do doc toString 80. We'll start with 80. Okay, so this is just I'm wrapping this in a block so that we can do this use and we don't have to have any other stuff. Oh, Okay. Yeah. We have circular dependency there, so that's not going to work. Well, let's just put it in pretty. Yeah, that's not going to work either. All right. Put it into the freaking top level. We're going to... Now we can just Gleam run. Okay, so we've got an issue here with circularity still. I think it's... we don't need it in there anymore. Yeah. Fine. For Pete's sake, Gleam IO. Thank you. Gleam result. Okay, we need import glam doc. What else? Or do result map. What's not matching there? I think we need to replace error. Yeah, because the issue is these two functions don't return the same result type. Now we can actually do this another way. We don't need use. Let's do let assert okay tokens is this. And get rid of that, and then we can say let assert okay p is parse.parse. And then we can say this, yeah, because there's like no reason to be defensive here. Okay. Okay, so we have a successful round trip. That's actually a really good test, right? Let's see what happens if we do like 40. It's still small enough. Let's do 30. Still not breaking, and I think that that's probably wrong. Yeah, it's definitely not breaking onto new lines. So what would I like to see? I think what I would like to see is if we are supposed to break onto a new line, that the break happens after this, right? But those are glued together. And then we get the indentation. So let's go back into here and see how we can get that. And I think it's really just like here, rather than this, we want space. And we don't want flux space. But we might, well, but our parenthesize does the grouping. So let's see if we just change that, what happens. Okay, so for 80, it's not going to break on anything. Let's see what happens when you switch it down to 40. Okay, so now we're getting it indented, and those two are aligned. That's fine. Let's break it down to 20. Okay. I don't particularly like this, but that's fine. Let's see what happens when you get down to 10, really narrow. Yeah, okay. I'm actually okay with this. The main point is that, first of all, the parens hug the last line, the closing parens hug the last line of that expression, and the opening parens hug the first thing in the parenthesis. So I think that kind of does what we want. Okay. Yeah, good stuff. I think I would like to continue. I don't know about the rest of you, but I feel like I want to continue. Before we go on, let's grab some other sample program like this one. This is good. Let's throw it in here and see how it gets pretty printed. Okay, so we have some things that we need to deal with here. First of all, our lets didn't come out right. Yeah, that was a good thing to test. A lot of this looks okay. Like, note that the while loop and the sum line up. It's interesting that this did not get broke here. Ideally, we would like it to look like, you know, with the correct amount of spacing, of course, we'd like it to look like let and the binding occurs on the same line, preferably. kind of like it to look like that. No. Like that. That's what we want it to look like. Okay. Let's see how we can make that happen. And I do want to take, like, I want to continue because I feel like this is a nice thing to do. But I'm getting to the point where I need to get some more water. So I might take a break. All right. What is the deal with begin? I think it's the interaction of begin with let, because note that begin and while actually look like they're behaving correctly. It has to do with let. And how do I tell it? I mean, I feel like I'm already telling it to break here. It probably has to do with grouping, because if this inner one needs to break, I want the parents to break as well. But if we have something that looks like, you know, let x5 x, there's no reason to break. Right? But if it's like begin and then, you know, like what we have below, we definitely want to break on that. Now, some of it could be that what we're doing here is this forces a line break. We could just say let always forces a line break, and that would solve the problem, right? I don't particularly like that. Yeah, so then we get it coming out correct. But on a case where let me pull this out. Okay, then we can change this out more easily. So if I have like I was showing on in the comment there, I don't want that to break, like, because that looks ridiculous. So I think that we need to read through this one with the nesting and to-do lists. You know, they have this example here, and it's printed like so. There is something with like force break, right? Okay, and so there's this interaction between group and force break that's interesting. So if you group something, then it's going to ignore it. Maybe that's the root of our problem. Or rather, you can only force break inside a group if you want the things in there to wrap. All right, I'm going to take a brief break and we'll be right back after I get some water. All right, we're back. Thanks for bearing with me. Let's figure out where we are. Okay. So our fundamental problem is basically we want to break. If we have to break, we want to break here. So like that needs to be an optional one. But we don't want to break here if we can avoid it. I feel like there needs to be something like a sticky space. It could be that what we do is we make that into a group. We kind of already have that. But the problem we were seeing, if we scroll up here, was before we told it to explicitly break lines like this, we were getting it sticky here, like where we don't want it to be sticky. I think what I wanted to look at is how can we tell the parent document to break if an inner one is. And maybe we just need to go through now their tutorial's actually wrong. This is not JSON. This is valid JavaScript, but it's not valid JSON. Okay. We've been using this concat join a lot. Yeah, I think right, this, I don't know why. This must be an implementation detail. While my nest has to come before the closer on a wrapping construct, but right, so this is showing like we have a similar problem here. When you're outputting a field of a JSON object in this tutorial, you take the name, and they're doing that incorrectly. It needs to be quoted. But assume it's to JavaScript, not to JSON. Then you have the colon. Then you have an obligatory space. I feel like I need break prioritization. Maybe that's not a thing. Okay, and this was just like they're extracting, you have arrays and objects and so forth. I built on top of their example, I put the soft breaks in here so that when you printed it out on a single line, like the field's going to hug. But when you print it on multiple lines, it's going to be, it's going to break after the opening and before the closer. Which is fine. Okay. The other thing to think about is like, this is a similar problem we would run into if you're trying to write a YAML formatter, like a YAML outputter, is if you have an array in YAML, you can put it on one line, but you can also break it over multiple lines with dashes, almost like bullet points. But you want different formatting if you're going to break versus if you're not going to break. So what I don't know is if there's a possibility. Okay, let's read some more docs, but I don't know if there's a possibility of having different behavior if you break versus if you don't. So a document after which the pretty printer can insert a new line. New line is added after a break document if the group it's part of could not be rendered on a single line. So if we think about it in terms of groups, then maybe what we need to do is judiciously insert groups where we haven't been. Now we have in because our parenthesize thing creates a group, right? So maybe that'll be interesting. Maybe we just look at this debug. Let's try that for a bit. Doc.debug. And we can maybe see what that looks like. Okay, what do they say? Groups are surrounded by square brackets. Nests are surrounded by angle brackets and have a superscript with the nesting. Concatenated documents are separated by dots. Breaks are surrounded by curly brackets and show the broken and unbroken versions. Lines are rendered as the string line feed followed by superscript number of lines. Okay, so they're saying this is a group. The stuff in here is indented too. You have that. This is one thing, which I kind of expected. Then you have a line feed, and yeah. let's do that and see how it changes. So that's just space. Say flux space. See how that comes out differently. Yeah, it's just called flux space. Boo. We can actually go in here. Note that's break with, yeah. Soft break. We can see the actual constructions of them. Space. Yep. Flux space. Okay, so that has a different variant. So if we look at this, let's see all the places where okay, that's the debug bits. Um, I don't know what the answer is here. So I remove this. It should go in one line, but if I put this back, then it doesn't decide to break until here. And that's because our begin I wonder if we do doc force break. I don't know if that makes any difference. That kind of makes some things weird. That's probably not going to look right. I probably just messed it up. Yeah. Actually, I don't want soft break. I just want space. Oh, that's interesting. Look at how that soft break made it force to the next line. Wild. What if I do space there? Maybe that's what we needed. If we go back and try our other program. Does that get printed on the same line? Yes. Okay, so I think it was the interaction between begin and let and the flex space there. So I think we want something similar with the while loop. Oh. Okay, that's actually not going to do anything special there. We need to put our other program back. That looks good. I don't know if I've solved it, but it feels better. Okay. All right, so how far can we go with this? Let's look at our passes real quick. Our first one is shrink. It does not use a new language. Our next one is here. Show me table of contents. Get rid of the search, please. Table of contents. Okay, we need to go back to here. So shrink. And then uniquify, which does not introduce a new language. Right, so we can see it here. It's shrink, shrink is fine, uniquify. Expose allocation produces a new one. So we could do I have a hard stop at the top of the hour, but where I'd like to get to is let's update our UI. Now that we have two languages, let's update our UI such that we can select the phase that we want to stop at. So we can do shrink and uniquify and then explicate control. And we'll you know, we will eventually have the option to do sorry, we'll have the option to do these others. The x86 one won't be hard. So, okay. Let's look at the UI. So I did fix that text. I think that we can do Gleam run Luster dev. I think that's it. Start. Okay, so we, this is, we can open up the browser at, yep, right like that. And we're getting nothing. Why are we not getting anything? Oh, that's fun. It printed something at the console, but we get nothing. We get nothing in here. That's fun. Oh, I know why. It's because it's entering this, and this IO print line is defined as console log. So what I need to do is comment this out, and we'll put this back in. So we're gonna rebuild. All right, and now we've got the UI that we have on the main web page, right? Except I fixed the text. Okay, so we need to define we're going to define a new type that we can do like which pass to stop at, right? So we have shrink, uniquify, and where's our uniquify? Expose allocation, we haven't donelalloc. I don't want to go into those. We can do explicate control. So we've done ltup and ctup as far as the languages that the intermediate forms that we need to produce. We need a pretty print, and then the others we have not done pretty printing for them. So I want to get to the point where we can actually do the select and compile it to this phase and then pretty print that. So pass and explicate control. And then let's make a quick function, pass to string. P is a pass, and then string, case P. And we'll do explicate control. I'm just making these so that we can put them in the dropdown and they look like one would expect rather than this. Okay, our model is going to be, input, output, and pass is going to be pass. Let's just add it in here. And the default needs to be, let's say, explicate control as the initial. Okay, so now we're going to do I did some kind of fancy Luster UI button in here. Or did I just like copy and modify this? I think I did. So I'm going to put a select in here. And we'll say theme use primary. I think that'll work. Actually, use base. So for select, aka a dropdown. You need to have options in here. And I'm trying to remember what event. So let's look at MDN HTML. So for a select, HTML element reference. I don't actually know if like what are the events? And actually I probably want like web HTML. I want this selector, this searcher, HTML select element. Okay, so what events does it respond to? The change. So when the user selects an option. What is an option element? HTML option element. Does it respond to any events? All right, let's look at this. The other thing that we can do is say event.onChange. Okay, decodes the string value of the input and passes it to the message fetch. So that's actually what we want here. And that's actually up here. So we have input updated, and I wanted to have a message which is pass selected, and the pass is a string here, and then we can just say that this on change is pass selected, right? And then here, okay, fine, add it to the end. We'll do the reverse of this. And so let's do case S and go explicate control. And we'll have shrink is shrink. And uniquify is uniquify. And then anything else, we're just going to say, if you were able to give us bogus, we'll just pick explicate control, just to cover the empty, or like the unknown case. So if we have this, we're going to say model, and we'll say pass is string to pass. Okay, so we're updating which one is selected, right? Okay, so now what we need to do is the children of the select need to be options. So we're going to take we'll just say HTML option. And I think I want to make a up here like a const pass order is a list of passes, and that's going to be in the order that we have above, uniquify, explicate control. And then we can map over this into making our options. So we can say the children of this are pass order list.map, and this is going to take P, and we're going to say HTML option. So we don't know what the attributes are there yet. And then the contents of that are going to be HTML text, and this is pass to string of P. We can start with that. I'm going to import Gleam list. I'm surprised it's not in here. Okay, what's wrong here? Oh, we don't need this text. It's just what is the contents of this? It's just a string. Okay, so let's go back to our page and see how awful it is. Okay, so we've got shrink, uniquify, explicate control, so forth. We're going to have to can we do use primary? Does that do anything? Not really. But we got a drop down, it's got our different phases, and we're setting the model. Okay, so this is exactly what I wanted to do with the UI, except that I would love it to look more pretty. So let me look. This is, yeah, I guess I just copied this in. Yeah, because I think Lustre UI was not building, I think was the problem. Let's look real quick at that repo. Haley.dev, or maybe it was Lustre Labs. Yeah. Let's see if there's a select. Not really. Yeah, there's some primitives in here. Like Haley has not done anything with this. I think that's because she wanted to make some changes to Lustre itself. So I mean, I don't think that this is there's combo box. Is combo box what we want? Okay. Well, for now, let's just keep with the basic select and attribute dot selected, and here we're going to say model dot pass equals p. So then, not that we really need that, but if we're reconstituting the model, we won't lose it, right? So if I inspect this select, I should see that explicate control has selected on it, right? So if I change to uniquify, now uniquify is selected. And I think that's basic browser behavior, but it is showing that it's going through correctly on that. Okay, so our last step, and we've got about 40 minutes left, is we need to I think I need to move this into compile, this particular thing. And we'll say type pass. And I'm going to move this in there. And I think we'll say pass order. We'll move over there. Pub and pub. Okay, so let's also move these over there. String to pass, pass to string. And then that'll just take care of keeping this all in the same place, and I don't have to worry about the different, what belongs where. Obviously here we can do something else. Ultimately we would want this to be prelude and conclusion, but we're not going to do that today. So I could say default pass, let's say default last pass is going to be a pass, and that's going to be explicate control, and then we can use that here, and then when we go and we add the other phases, we can throw them in here, and then this will be what am I trying to say? This will be able to be changed directly, and then it'll just default to the thing that we're trying to do there. Okay, so the next thing I want to do is change compile and say pass is a pass. The other thing, interestingly, that we could do is have one where it stops at tokenization or at parsing. In fact, we could even do that. Let's go ahead and throw in here parse and type check. And then we'll say parse is parse. type check is type check. And then we can do the same down here for these. Do the reverse. We could potentially do a dictionary here, like a bimap type of situation. Because we have the opportunity to like treat those as separate phases. Okay, so now, you know, this is error not implemented. We are going to fix that. But we are going to say we definitely need this, right? And I think that since parse is the first one that we can stop at, okay, so here we're going to do case pass. And let's add all the missing patterns. And I want to make sure that these are in the order that they will be executed as cases. So this is really just if we want to stop at parsed, then we're going to do L dot, and here's the thing is we need to change this to L toop. And yeah, that's fine. We're going to restore this. Sorry, I'm just making sure that we can go. We should never have that, but I need to make sure that we can do that. Okay. We can restore the interpret call. Okay, so if we have the program, we want to format the program, and wrap it to 80 columns. Okay, so that's the easy one. So for type check, we'll do something similar. We'll say program, and here's where, so result try, okay, so that one needs to be wrapped in OK because it doesn't return a result. So type check will be So we need to do this map error business again. And we're calling l.typeCheckProgram on the program. And we need to map error with string.inspect. So I think that this is, we ultimately call result map. And then that's basically this all over again. But I'm using result map because this also returns a result, so. Okay. So then we'll do something similar in these next phases. And actually, let's just copy the whole thing. Guys, I know that this looks tedious right now, and you're like, geez, Sean, are we ever going to see the results of this? Bear with me. We're almost there. We're going to see it before the end of the arrow, I guarantee you. Okay, so this one, if we type check the program, and that's fine, then we can call shrink dot shrink, right? Because that will run the shrink pass. And then we'll get out a, and what does shrink do? Shrink removes and or, and replaces them with if. And then uniqueify. So now we need to do, now there's something to be said that we should be able to do, these should all be results, right? I think that for the ease of piping, I didn't have these passes return results, because in that, ultimately we should do that, but then you get the same things that you see in Rust that are like really satisfied by the question operator. You know, the question operator rather makes that easier. We will get those results polluting everywhere. And there are places where we just decide to panic, right? Okay. So this one is a big leap of faith. And I want to put some comments in here that we will have other passes a few moments later, passes later. Because we are going to do, we're going to get import EOC langs, and we want ctube as C, because we're going to run a bunch of these things. The main thing that I want to be careful about with, yeah, see, that's what we were doing down here before. The main thing I want to be careful about with those panics is that I don't know what the behavior is on JavaScript. It might just console error, might just throw an unchecked exception. I don't know. Okay, so ultimately we want C format program. Well, we can copy all this business. Not expose allocation. Right, so we want all these. Just going to copy all that into here. Okay, so now we need to import expose allocation. Hopefully it'll let me just do that. Yeah. Okay. So we don't have uncover live. I'm just going to comment out these things that are going to make the compiler make a lot of noise. Okay, so over here, yeah, we're going to make explicate control. We're going to import that explicitly. Actually, we can just say compile dot there for simplicity. Okay, so then we say model.pass. So we pass that to compile. All right, let's see if our stuff works. Probably not. Okay, so let's start with shrink. Oh, and I meant to put in here, I think I just probably need to restart. Yeah. Okay. Okay, so now, why do we not have... Oh, right. So I need to put parse and type check in here in order for those to show up in the UI. Okay. So let's select parse and let's just say 5. And that's fine. Let's say type check. Okay. Shrink. Obviously, these are not doing anything. Uniquify. Explicate control. Start, return 5. Isn't that fun? Okay, so we actually got, we got the fruits of our labor there. Let's do something more complicated. Let's pick one of our examples, like from a test. One that's preferably in text. Yeah, so let's pick this one. Right? Okay. This will be an interesting one. Okay, so let's start with parse. We do have some interesting things here with the line breaking. We'll want to possibly address that, similar to how we did for begin. So here's a problem with our pretty printer. When we are in L-tube, we have a Boolean value. Where is that? Okay, this is not bool to doc. We have a case value, and if it's false, we want doc from string %f, doc from string %, or not %, bang f bang t. Okay, so we found a bug. All right, so let's try parse again, paste in our program. Okay, so we are keeping true to be actually hashtag. Are you the creator of Gleam? No. No, Louis Pilford is the creator of Gleam. I just love using Gleam. Okay, so there's what happens with parse. Let's look at type check, and we should get the, yeah, so you can see here, the has type gets wrapped around that vector. Sweet. Oh, this is what I wanted from the beginning. Okay, so shrink is only going to remove and or, so we should see no change there. Right, that doesn't do anything. So we select uniquify, and you can see the transformation that's done is it subscripts those variables such that they're ensured to never be reused. And now let's go all the way to explicate control. Yikes. Okay. So let's find the start. Yeah, here we go. Let me get rid of the web inspector. Oh, I love this. This is what I wanted from the beginning, and we got here. We'll make this a little bit better. Okay, so here in start, remember we got so it's creating variables for each of the fields of the vector that it's initializing, and then it's, you know, we're doing the garbage collection dance here of, is our free pointer, you know, are there 24 bytes that we can allocate? So if you know, adding 24 bytes to the free pointer doesn't reach the from space end pointer, then we can go to block 4, which is don't do anything. If we don't have enough space, then it's, hey, call into the garbage collector trying to get me 24 bytes, and then go to block 3 on both of these. So block 3 allocates a vector of size 2, and it has the type integer and boolean. Remember, these are used for generating instructions for how to access those fields. Really, it's more about the what is the tag on that vector on the heap. What language are you building? So we're working from a book called Essentials of Compilation. We're building a Lisp-like language that compiles to x86 assembly. And these are the phases that it goes through right now. This is we're doing the incremental approach, which is basically you add, it's incremental in 2 dimensions. One is that you have very small phases that do very focused things in your compiler so that your transformations are easy to understand. And the second thing that it is that we don't build the whole language from the beginning. It starts from a very small, very focused language, and you add features as you go. So that you add features and you go through all the passes that you've implemented and update them or add new ones as needed. And you get something that's, again, easier to manage. So we've been doing this since February or March, about 2 hours at a time. So there are a lot of back episodes if you want to go check them out. Okay, this is awesome. We have another pretty printing problem here. Look at this. If temp.4 equals true. So we have 2 problems there. One, this should be EQ question mark. And I think I need to do that in the higher level as well. And this, well, this true is fine to be true here rather than 1. I think at this level, yeah. But this definitely needs to be EQ question mark. We might say that that's hashtag T. Yeah. No problem. Welcome to the stream. Thanks for coming. I'm going to be wrapping up in the next 15 minutes or less. But let's go and fix that little bug. So what do we got here? Yeah, and I think it's actually in here because we do format the comparison operator. Right, so this should be not equals, it should be EQ question mark, right? Okay. And can we paste our thing again? Right, so now we get EQ question mark. And I think that we should have a format atomic. Oh, I'm in the wrong file here. Yeah, we may not use this bool to doc. Let's just copy that from here, where we change that. Yeah, just copy it into here because we're gonna. I want to make sure that we are showing that these are, you know, from the same place, even though there's no hashtag true in C. Honestly, it should be all caps true, right? Probably. Oops. Did I do anything there? No, I think I just scrolled that up. Okay. Not wrong one. Where's our example? Yeah. Here we go. So this is what we are working from. I need to deal with some like focus things here, but like there's the output of parse. Again, the line breaks are not great there. Type check throws in the type, then we get the line break. Shrink doesn't do anything because there's no and and or. Uniquify, subscripts. Then we jump all the way to explicate control. Okay, so now we're getting T, hashtag T, right? The other thing that might be interesting here is that since, no, it's fine. We've got hashtag T there. Remember, it's not actually C. It's a C-like language. The main thing here being the 3 address code form. Okay. I think this is a great place to stop the stream. So even with the minor bugs in our stuff, let's go ahead and add everything that we did today. So this is our bonus stream. We did add pretty printing to CTOOP and LTOOP, and hook up the web UI to that. Okay, I'm going to push to main. And then I'm trying to remember what we did last time we exported to the website, because I want you to be able to see that, what we just did, and play around with it on my website. So, and that'll be a good place to stop. I think, let me see here. Looking at this, yeah, I should go up here. Oh, right, I made it relative. So I can so let's look here. What's in here? Yeah. So it has this priv static directory, which is the compilation output of Lustre and the Gleam JavaScript compiler. And yeah, so I don't think the index.html has changed. Code essentials. Really? Yeah, there's no diff between those. So we can just copy our priv. Okay. Except I got that. Let's priv. We duplicated it. And let's just copy it here. Yeah, okay, so okay, and this is my personal website. I don't share the repo for this, but I'm just gonna update to the latest essentials of compilation. I don't have an automatic pipeline that does this. That would be super nice, but I don't do that. So we're just gonna push. Oh, I haven't renamed the main branch on this repo. It's that old. Okay, so we should be able to go to well, when it builds. GitHub.com. Yeah, so this is running the GitHub Pages build. That uses I think a default action on there. And deploys it. And we're good. So I can close that and we can go to seancribbs.com, Essentials of Compilation, and force refresh, and we've got the updated one. So y'all can go play with that. And thanks for coming on for a longer stream today. It was really fun, and we'll be able to build upon this in future streams. So thank you. All right, have a good one.